Okay, new section 1.3. Like we talked about last week, chapter 1's a lot about just kind of laying the foundation, what geometry is all about. So a lot of it's just going to be definitions, that type of thing. So we can do some work later in the book. First definition, not too much rocket science going on there. Midpoint, you see the root word mid, do you think what? Middle, yeah. It's the point dividing a segment into two congruent segments. So it's not only in the middle, but it's dead smack in the middle. Splits it into two congruent segments. So this would be an example. You know, if you look at A, B, and C, which one would be the midpoint? B. And what do these little hash marks mean? Those lengths are equal. So we'd say AB is congruent to BC. Another vocab word we got here is a segment bisector. Okay, segment bisector. It could be a point, a ray, a line, another segment, or even a plane that intersects a segment at its midpoint. Now when you think of the root word bi, a lot of times I'll talk about Greek roots. Okay? Root word bi, what does it mean? Kit? Two. So a segment bisector literally cuts a segment into two equal pieces. B is a bisector. It cuts it into two equal pieces. If I drew a line, a perpendicular line through B, that would bisect it as well. Okay. So there are two vocab words. That's kind of nice. Okay, so let's jump to example 1. Find segment lengths. Let's see. What point's the midpoint up there? Harmony? T. Okay? T. It bisects R and S. T is the midpoint. So if we know RT is, oops, if this is 21.7, what else is going to be 21.7? TS, yeah. Midpoint. It just cuts the segment in half. So if we're trying to find the length of RS, the whole thing, that's not too bad. What do we got to do? What do you think? We know if this is 21.7, we just said this is 21.7, so how do we finish it off there, Farley? Add them. Yeah, we just add them up. We take RT plus TS, take the two segments added together, so 21.7 plus 21.7, and who's good with their mental math there? Kit? What'd you say? 43.4. You got it. The length of RS is 43.4. Okay. Now a lot of times we'll go through an example and then we'll do a checkpoint problem. When they're more basic like this, I'm not going to worry about going through checkpoint problems. I think it's more valuable to give you guys some homework time. So we're actually going to skip this. We're going to jump right to example 2. I like example 2 because now it's going to tie back to last year. We're going to use algebra to solve this thing. Okay, it says point C is the midpoint, so it cuts BD in half. Find the length of BC. And all we know is that if C bisects this segment, they got the little hash marks, they tell us this segment equals this segment. So what equation could I set up to try to find the length? All I know is that those two sides are equal. So how do you think I could set it up? What do you think, Roberts?
3x minus 2 equals 2x plus 3.
Yeah, if I know the two sides are equal, set them equal to each other, create an algebraic equation. Now it goes back to chapter 3 from last year when you're solving equations with variables on both sides. Actually, we answered a homework question like this too. What do you think? Get your variables on one side. Should I put them on the left or the right? Left. I mean, theoretically you could do it to either side, but I like putting them on the left because you've got more there to begin with. And if you subtract 2x from each side, I wish they gave us a little more room, but I'll subtract 2x from there. And I'll subtract 2x from there. Bam, they're gone there. What do I have remaining on the left side? An x and a minus 2. And over here I've got a 3. Yeah, if I put them on the left side, that way I've got a positive number of x's. I never have to worry about negatives. Okay, last step. We got one last step to finish off here. What do we got to do? Dana?
Subtract 2.
Well, we're going to get rid of the subtract 2, so we would add 2. Yep, little fence post in action, add 2, so we get x equals 5. Now we're supposed to find, we found what x is, but that wasn't the question. They asked us to actually find BC. So now we want to evaluate, plug and chug. When x is 5, what's BC going to be? Well, it's going to be 3 times 5 minus 2. So I got 15 minus 2, I've got what? Yeah, 13. Length of BC is 13. Again, not too bad. I like it because it ties geometry in with stuff you guys did from last year. I'm glad, one thing this book does a nice job of is incorporating algebra into it, which is important because you guys on the MCAs are tested on what? 8th grade math, algebra, and you're taking 10th grade math. Okay? So it's going to be, you know, you're going to have to see that algebra throughout the book to keep it fresh. All right, we're going to skip that one. Now, how about what if I jump to this? Somebody tell me the midpoint of the blue line. Katie, what do you think?
Is 2.
Okay, the y-coordinate is 2. What's the x-coordinate?
X-coordinate is 4.
Oh.
3, sorry.
Yeah, negative. Because from 0, 0, we always start at 0, 0. It's kind of our origin. That's where we start. And we can easily see the midpoint. Hey, it's halfway between the blue dots. It's at negative 3. I'm left 3, and I'm up 2. Well, it's really easy to find that midpoint, isn't it? What about this one?
Yeah.
You think it's easy to find the midpoint there?
Yeah.
What do you think it is, Campbell?
2.5, comma, wait. Okay. I guess that's kind of hard.
2.5, 1.5?
Yeah.
Are we positive?
No.
It's a little harder to tell when it's on a diagonal, isn't it? Than when it's just horizontal or when it's just vertical and you just can count boxes. So what we need to do is we need to have a method for finding the midpoint of a line when it's not nice and simple like this. Okay, and we actually touched on it last year. I don't know if Kepnick's class got to it, but I know we got to it. It was the midpoint formula. We got a nice little formula for it. Okay? All right, so here it is. And it's really nice. All you basically do are doing averages. Okay, the midpoint formula, this is a really fancy way of saying it. Let me highlight the important pieces right here. Here's the first point. Okay, call it x1, y1. Here's the second point, x2, y2. How do we find that midpoint? Well, to find the average, or the x-coordinate, you just average the x-coordinates that you're given. So add up x1 and x2, divide it by 2. To find the y-coordinate, average the y-coordinates, add y1 and y2, divide it by 2. So you're really just finding averages. Not too bad. Okay, so here's your midpoint formula that we're going to use throughout the course of the day. Let's take a look. Let's apply it once here. It says find the midpoints. If the endpoints of PR are negative 2, 5, and 4, 3. I don't want to have to go and graph this thing and plot the points. So how could we use the midpoint formula to find the midpoint of this segment? What do you think? What would we have to calculate? I guess they did draw it for us. They drew it for us, and boy, looks pretty evident that it looks like what? 1, 4? Let's just double check to make sure with that midpoint formula just to practice it. Okay, what would I plug into the midpoint formula? How would I find the x-coordinate? Roman, what do I have to do?
Add x, like the x-coordinate.
Okay, what are the two x-coordinates?
Negative 2 and 4.
Okay, add the x-coordinates. Negative 2 plus 4, and then divide it by 2, right? Well, negative 2 plus 4, that's going to give you, and 2 divided by 2 is? Okay, that checks out with what it looks like. How about the y-coordinate? What do I have to add to get the y-coordinate? Andrew?
5 and 3.
Yeah, 5 and 3. The two y-coordinates. We got 5 and 3. 5 and 3 makes 8. 8 divided by 2 is 4. Hey, it checks out with the picture. The coordinates of the midpoint are 1, 4. Okay, not too bad. Right? Not too bad. Again, with these more basic ones, I'm just going to give you kind of a refresher. We're not going to take time. I'd rather have you have homework time than to practice another one here. So we're going to jump to part B. How is B different than A? Dana? Yeah, we've got an endpoint and we've got the midpoint, but we do not have the other endpoint. We got to figure it out. Well, you can still use your midpoint formula. You just have to work backwards. You have to use a little algebra. Key is knowing how to set it up. How do you think we'd set this up? Rouse, I hear you talking. What do you think there? You're thinking, man. I can see it.
Well, we have to multiply the midpoint according to 2.
Okay, so when you think about trying to get this x by itself, you're going to have to times something by 2 to get rid of that, right? What would I have to have here, though? And when I find the midpoint, let's see, I add the 2x coordinates and I divide by 2. So, well, x, that's the endpoint I'm looking for. What's the other x? Farley? 1. If I were to find the average of these 2 points, I'd add 1 plus x and divide it by 2. So let's do that. Okay, I got 1 plus x divided by 2, but equals what? Rouse? 3. Yeah, I know the midpoint. They gave it to me. The x coordinate was 3. So if I average 1 and x, I get 3. Well, then it's just algebra from there. Like Rouse said, multiply both sides by 2. I get 1 plus x equals 6. So x is going to be 5. How about the y coordinate? What 2 things would I add to find the y coordinate? Nicole?
Add 6.
Yeah, if you wanted to find the midpoint of this segment, you'd add the y coordinates. What are the y coordinates? 6 and plus y. You divide it by 2, you'd find the average, and you'd get what? What do they tell me the midpoint is? They already gave it to me. Katie? 4. Little algebra, multiply both sides by 2. We get 6 plus y equals 8. Subtract 6, we got y equals 2. And bang, we've got the endpoint. Now, yeah, I could have just looked at the graph and said, there it is. But we're not always going to be given a graph to look at. Okay, so we have to be able to know how to do it algebraically as well. Okay. All right, we're going to skip that checkpoint problem. Let's jump to our last thing for today. We talked about the midpoint formula. The last one we're talking about is the distance formula. Okay. Comes from the Pythagorean theorem. What is that Pythagorean theorem? Probably say it before you even fall asleep at night. You'll never forget it. Farley, what is it?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. The sum of the squares of the legs in a right triangle is equal to the square of the hypotenuse. Or a lot easier, A squared plus B squared equals C squared. Okay. What you want to do is, God, to find that distance, I can't just count boxes like we did earlier. But if you think of it as a right triangle, you can use the Pythagorean theorem to find that. What's this distance? This is 1. What's this distance? More than 1? That's an acute observation. Very good. 4 and 3. This is 7. So how could I use the Pythagorean theorem to find that distance? What would I substitute where into this? These are always your legs. What are my 2 leg lengths? Yeah?
1 and 7.
1 and 7. 1 squared plus 7 squared equals the side I'm looking for squared. Oh, so 1 plus 49 equals C squared. Oh, 50 equals C squared. So C equals 50, right? Or C equals 25? What's the mistake I made? I divided by 2. How do you undo square? You square root. Okay. Now the reason I went through this a little bit in detail with the Pythagorean theorem is sometimes people see this big long distance formula and they say, where in the heck does that come from? Okay? This distance formula right here in your notes, where does that come from? Because it should look like this. Okay, y2 minus y1 squared. Okay, where does that come from? Well, think about what I did here. Okay, this distance right here, that's one leg of a triangle, right? To find this distance, you just subtract the endpoints. That's where they get the y2 minus 1. So basically, this is a length. Think of it as A. Okay, think of this as A. Oh, okay, well, there's A. Messy. And to find this leg, I just subtract the x-coordinates to find that distance. Well, think of that as B. Okay, so think of this as B. So I've got A squared plus B squared. Why the square root? Because this distance right here would be C, right? But I don't want that distance squared, so how do I undo the square? How do you undo square? You take the square root. So it knocks that out, and that's where you get the square root symbol. That's exactly what you guys just did in this example with me. You found one side squared plus the other side squared. Okay, you found what that was. And then you took the square root of it to find that. That's where the distance formula comes from. Okay, so if we use the distance formula in a fancy way on this one, what are our points here? You guys can tell me them. I'll forget them. What are the points? 3, 2, and what? -4, 3. Okay, so somebody tell me what I could substitute into this distance formula to find the distance between those 2 points. Hopefully we get the same thing. What do you think? Let's see. Maybe I'll go back to this for you. So I've got to find one leg squared plus the other leg squared. I find those legs by just basically subtracting the coordinates from each other. So somebody help me out. Roberts, what do you think?
-4 minus 3.
Sure, we could do -4 minus 3. Could I do 3 minus -4? Well, try it. What's -4 minus 3? -7. What's -7 squared? Positive 49. Keep that in mind. What's 3 minus -4? 7. What's 7 squared? 49. Does it matter which one you do first? No, because when you square a number, it doesn't matter if it's negative or positive. When you square it, it always comes out as the positive. What am I going to have to do right here? Or what could I do? I've got a couple options. Looks to me like he did the x-coordinates right here. What do I have to do here? The y's. So TK, what can I do?
Take 3 minus 2.
3 minus 2? I think we might have actually filled in this one, huh? That's fine. So we've got, what, -7 squared plus 1 squared. We've got 49 plus 1. Looks pretty similar to the example we did earlier, or how we worked it out earlier. Now, square root of 50. Again, what do the two wavy lines mean? About, we're approximated. Let's always go to 2 decimal places. Now, anybody think they could estimate it without a calculator? Estimating square roots. Are there any perfect square roots around 50 that you guys know? Dana? 49, what's the square root of 49? So this is going to be 7 point something.
7.12.
I don't know. Wait a minute. I've got 7.07. How many? Oh, okay.
I was closer.
All right. We're good there. We talked about that. We don't need a checkpoint problem. I think we're ready to go on some homework, okay? Midpoint and distance formulas.